this is the first one of x is 1.5. So it is to determine the value of the following logarithmic functions. So if we check, let 1 point before starting the sum. So if log n base a equal to x, then a power x equal to n. So first one we have here log 25 log 5 base 25. Let it be equal to x. Then 25 power x equal to 5. 25 can be written as 5 power 2, 5 square whole power x equal to 5. A power m whole power n is a power mn. So 5 power 2x equal to 5 power 1. Bases are equal, equate powers. 2x equal to 1, x equal to 1 by 2. Since log 5 base 25 is equal to x, it will be equal to 1 by 2. So log 5 base 25 is 1 by 2. Next, second one, we have log 3 base 81. Log 3 base 81. Let it be equal to x. 81 power x equal to 3. And 81 can be written as 3 power 4. 3 power 4 whole power x equal to 3. And again a power m whole power n is a power mn. 3 power 4x equal to 3 power 1. Bases are equal, equate powers. 4x equal to 1, x equal to 1 by 4. So log 3 base 81 is 1 by 4. Next one, third one. What do we have for third one? Log 1 by 16 base 2. So log 1 by 16 base 2. Again let it be equal to x. 2 power x equal to 1 by 16. 16 is 2 power 4, so 1 by 2 power 4, and we know one point. A power m is equal to 1 by a power minus m, or a power minus m equal to 1 by a power m. Therefore 2 power 4 will be equal to 2 power minus 4. 1 by 2 power 4 will be equal to 2 power minus 4. So bases are equal, equate powers, x equal to minus 4. So log 1 by 16 base 2 is minus 4. What do we have for fourth one? Fourth one, it is log 1 base 7. Let it be equal to x. 7 power x equal to 1. And we know anything to the power 0 is actually equal to 1. So 7 power x equal to 7 power 0. Bases are equal, equate powers, so therefore x equal to 0. Therefore log 1 base 7 is 0. Next, fifth one, we have log root x base x. Let it be equal to y this time because we shouldn't have any confusion. So x power y is equal to root x. Next, x power y, this root x can be written as x power 1 by 2. Can't it be written as, root power 1 by 2 is actual root x, right? So root x equal to x power 1 by 2. Bases are equal, equate powers. So y equal to 1 by 2. So log root x base x equal to 1 by 2. Next we have log of 512 base 2. Sixth one, log 512 base 2, let it be equal to x. 2 power x equal to 512. And 512 is actually 2 power 9. So 2 power 9. Bases are equal, equate powers, x equal to 9. So log 512 base 2 is 9. Next, what do we have? Log 0.01 to the base 10. So seventh one, we have log 0.01 to the base 10. Let it be equal to x. 10 power x will be equal to 0.01. And 0.01 can be written as 1 by 100. And 100 is 10 square. So again a power minus m function here. 10 power x equal to 10 power minus 2. Bases are equal, equate powers. So x will be equal to minus 2. So if x equal to minus 2, log 0.01 base 10 will be minus 2. Next we have eighth one. What is eighth one? Log 8 by 27. Log eighth one. Log 8 by 27 base 2 by 3. So let it be equal to x. So 2 by 3 whole power x equal to 8 by 27. 8 can be written as 2 cube and 27 can be written as 3 cube. So 2 cube by 3 cube. This can be written as 2 by 3 whole cube. Again similar to the above sums. Bases are equal. Equate powers x equal to 3. Therefore log 8 by 27 base 2 by 3 will be actually be equal to 3. Now last one we have here 2 power ninth one 2 power 2 plus log 3 base 2. We can write this as 2 power 2 into 2 power log 3 base 2 because a power m into a power n is a power m plus n. So 2 plus log 3 by 2. So I mean log 3 base 2. So we have one small point here. The point is if a power log n base a, if that is LHS, we get RHS as n. A power log n base a equal to n. So if we compare, here a is 2 and n is 3. So 2 square is 4 into 3 will be actually be equal to 12. It is quite different from other sums and all the other 8 sums are same. I hope you understood it. It was pretty easy, right? Sum. So we have second sum of exercise 1.5 here. So it is to write the following expressions as log n and finding their values if possible. So before starting, let's have few formulas as let's take first point log x plus log y is equal to log x into y. Second point log x minus log y is equal to log x by y. Third point log a power n is equal to n log a. Fourth one log 10 is 1. Fifth one log 1 is 0. And last one log a base a is 1. So let's have first question. The first one is log 2 plus log 5. So first one we have first formula log x plus log y is log x into y. So log 2 plus log 5 will be log 2 into 5 which is log 10 which is equal to 1. Next second one we have log 16 base 2 minus log 2 base 2. So second formula here log x minus y, log x minus log y, it is log x by y. So log 16 by 2 base 2. We'll get 2 1s are 2 8s are 16. Log 8 base 2. Similar to the first question of exercise 1.5, let us take it as x. It will be 2 power x equal to 2 power 3. I mean to say 2 power x equal to 8 is equal to 2 power 3. Therefore x equal to 3. So log 8 base 2 is 3, which is log 16 base 2 minus log 2 base 2 is 3. Next, third one, we have 3 log 4 base 64. 3 log 4 base 64. We have a formula, third formula, log a power n is n log a. So here we have n log a, which will be equal to log a power n. So this will be equal to log 4 cube base 64. What is 4 cube? 16 into 4 is 64. So log 64 base 64. And we have last one here, sixth one, which is log a base a is equal to 1. So log 64 base 64 is 1. So therefore 3 log 4 base 64 is 1. Next, fourth one we have here 2 log 3 minus 3 log 2. What do we have? 2 log 3 minus 3 log 2. Again, n into log a is equal to log a power n. So this will be log 3 square minus log 2 cube. So log 9 minus log 8. Log x minus log y will be log x by y. So log 9 by 8. So 2 log 3 minus 3 log 2 is log 9 by 8. Last but not the least, we have the fifth one. So what is the fifth one? Log 10 plus 2 log 3 minus log 2. Log 10 plus 2 log 3 minus log 2. So second term is as a log n. So I mean to say n log a. Let us write it as log a power n. So it will be log 3 square minus log 2. Log 10 plus log 9 minus log 2. According to the DMAS rule, we have to add first and then subtract. So log 10 plus log 9 will be equal to log 10 into 9 from the first formula. Next, log x minus log y is equal to log x by y from the second formula. So we'll have log 10 into 9 by 2. 2 1s are 2 5s are. It will be equal to log 45. If we actually see the question, they told to express as n log a, I mean to say log n, and to specify the n values. So in the first question, n will be equal to 10. Second question, n will be equal to 8. Third question, n will be equal to 64. Fourth question, n will be equal to 9 by 8. And last one, we got n is equal to 45. This is the third one of exercise 1.5. So we have to evaluate each of the following in terms of x and y, and we should, if it is given that x equal to log 3 base 2 and y equal to log 5 base 2. So before starting the sum, let's have 2 points. First one is log x into y is equal to log x plus log y, and second point, log x by y is equal to log x minus log y. So first one we have here log 15 base 2. This 15 can be written as 3 into 5, and log x into y is log x plus log y, so this will be log 3 base 2 plus log 5 base 2. But log 3 base 2 is given that it is actually equal to x, and log 5 base 2 is y. So this will be x plus y. Next, second one we have log 7.5 base 2. So 7.5 can be written as 75 by 10 base 2. Next, second point, log x by y is log x minus log y. So if we prime factorize 75, we will get 5 square into 3 base 2 and 10 can be written as 2 into 5 base 2. Next, first point, log x into y is log x plus log y. So log 5 square base 2 plus log 3 minus log 2 base 2 minus log 5 base 2. Here we get minus because it's the whole term should be multiplied by minus because it is minus 2 into 5 base 2. Next, we know that log a power n is 1 log a. So log 5 power 2 is 2 log 5 base 2 plus log 3 base 2 minus log a base a equal to 1 minus log 5 base 2. 2 log 5 base 2 minus log 5 base 2 is 1 log 5 base 2. So we get log 5 base 2 plus log 3 base 2 minus 1. So this will be equal to y plus x minus 1 or simply x plus y minus 1. Now third one we have log 60 base 2. So now 60 can be written as 2 square into 3 into 5 base 2. Next, first point log x into y we have log x plus y. So 2 square base 2 plus log 3 base 2 plus log 5 base 2. So log a power n is equal to n log a. So log 2 power 2 is 2 log 2 base 2 plus log 3 base 2 plus log 5 base 2. And log a base a equal to 1. So this will be equal to 2 into 1 plus log 3 base 2 is x plus y. So x plus y plus 2. Next last one we have log fourth one. We have log 6750 base 2. If we prime factorize 6750 we get 2 into 3 cube into 5 cube whole base 2. Next, first point log x into y is log x plus y. So this will be log 2 base 2 log 3 cube base 2 plus log 5 cube base 2. Log a base a is 1. Log a power n is n log a. So log 3 power 3 is 3 log 3. 3 log 3 base 2. Similarly, we will get 3 log 5 base 2. So this will be 1 plus 3 into x plus 3 into y. So this will be 3x plus 3y plus 1. Fourth sum of exercise 1.5. So it is to expand the following given 5 numbers. So first one we have log 1000. Now 1000 can be written as 10 cube, and we know we had few points, so we have few points. So log a power n will be equal to n log a. So therefore this will be equal to 3 log 10. Next, second question, we have log 128 by 625. So now let's prime factorize 128 with 2. So 264, 2 into 32, 2 into 16, 2 into 8, 2 into 4, and 2 into 2. So 1, 2, 3, 4, 5, 6, 7. So this will be, this can be written as log 2 power 7 by, now if we find factorize 625 with 5, 5 into 125, next 5 into 25, next 5 into 5. So this will be 5 power 4. So the second point we also had is log x by y. Log x by y will be equal to log x minus log y. So log 2 power 7 log 2 power 7 by log 5 power 4 will be equal to log 2 power 7 minus log 5 power 4. And what was the first point? Log a power n. So log a power n is n log a. So this will be equal to 7 log 2 minus 4 log 5. Next we are done with second one. Next, what is the third one? Third one we have log x square y cube z power 4. So let's do third one here. Log x square y cube z power 4. So there is another point formula which is log x into y is equal to log x plus log y. So since we have three numbers here, it will be log x plus log y plus log z. So we can write it as log x square plus log y cube plus log z power 4. And again by the first formula, log a power n is n log a. This will be equal to 2 log x minus 3 log y plus 4 log z. Next one, fourth one, we have log p square q cube r power 4. So we have to do Bodma's rule here. First we should do the division first. So log x by y is equal to log x minus log y. So this will be log p square q cube minus log r power 4. Next, log x into y is log x plus log y. So log p square into p square q cube is log p square plus log q cube minus log r power 4. And again by log a power n formula n log a, this will be equal to 2 log p plus 3 log q minus 4 log r. Next, fourth one is done. Last one we have fifth one, log x cube, under root x cube by y square. So fifth one we have log under root x cube by y square. So we know that root x will be equal to x power 1 by 2. So this we can write as, this can be written as log x cube by y square whole power 1 by 2. So by the first one we have log a power n is n log a. So this will be 1 by 2 log x cube by y square. Now we have log x by y, which will equal to log x minus log y. So 1 by 2 log x cube minus log y square. Now log a power n is n log a. So this will be equal to 1 by 2 into 3 log x minus 2 log y. If we multiply 1 by 2 with both of the 3 log x and 2 log y, we'll get 3 by 2 log 2 minus 2 by 2 log y. And 2 by 2 is 1. So this will be equal to 3 by 2 log 2 minus log y. Today we have the fifth question of exercise 1.5. It is, if x square plus y square is equal to 25xy, then prove that 2 log of x plus y is equal to 3 log 3 plus log x plus log y. So let's write what is given here. So we have x square plus y square is equal to 25xy. So we know one formula, one theorem, or x square x plus y whole square is equal to x square plus y square plus 2xy. If we bring this to left hand side, we'll get x square plus y square is equal to x plus y whole square minus 2xy. If we substitute this in the given equation, we would get x plus y whole square minus 2xy is equal to 25xy. If we bring this to the right hand side, we would get x plus y whole square is equal to 27xy. Apply log on both sides. On both sides, we would get log of x plus y whole square is equal to log of 27xy. We have two properties. First one is log a power n is equal to n log a, and second one is log x into y is equal to log x plus log y. If we apply these both properties, we would get 2 log x plus y is equal to log 27 plus log y, log x plus log y. And 27 can be written as 3 cube. 3 cube is 27. So 3 power 3 plus log x plus log y. And again we use the same formula, log a to the power of n is equal to n log a. So we would get 2 log x plus y is equal to 3 log 3 plus log x plus log y. Hence proved. This is the thing they told to prove. So we prove that 2 log x plus y is equal to 3 log 3 plus log x plus log y if x square plus y square is equal to 25x. We have the sixth one, which says log x plus y by 3 is equal to 1 by 2 of log x plus log y, and we have to find the value of x by y plus y by x. So to proceed, we have two properties of logarithms to use here. We have log of x plus log of y is equal to log xy, and log a to the power of n is equal to n log a. If we apply these both properties in the given one, we would get log x plus y by 3 is equal to 1 by 2 of log x into xy, and which is log x plus y by 3 is equal to log xy power 1 by 2. Since we have log on both sides, we can equate the numbers. So x plus y by 3 is equal to root of xy, and we have to square on both sides now. So x plus y by 3 square is equal to root xy square, and if we square, we get x square plus y square plus 2xy by 9 is equal to xy. If we simplify, we would get x square plus y square is equal to 9xy minus 2xy. X square plus y square is equal to 7xy. And now we must divide both sides by xy, x into y. We would get x square plus y square by xy is equal to 7xy by xy. If we distribute this denominator to the both of the numerators, we would get x square by xy plus y square by xy is equal to 7xy by xy. If we cancel here, square and x will get cancelled, square and y would get cancelled, x square, xy and xy. So now we have x by y plus y by x is equal to 7. So this is the value they told to find if log x plus y by 3 is equal to 1 by 2 of log x plus log y. The value of x plus x by y plus y by x will be equal to 7. When the question of exercise 1.5, it says 2.3 power x is equal to 0.23 power y is equal to 10 to power of 3, and we need to find 1 by x minus 1 by y. First, let's consider these both. We would get 2.3 power x is equal to 10 to the power of 3, and if we apply log on both sides, we would get log of 2.3 power x is equal to log of 10 to the power of 3, which would be x log 2.3 is equal to 3 log 10, and log 10 is actually 1, so x log 2.3 is equal to 3, and if we bring this x to the right hand side, we would get log 2.3 is equal to 3 by x. Let's consider it as first equation, and similarly 0.23 power y is equal to 10 to the power of 3. If we apply log on both sides, y log 0.23 is equal to 3 log 10. Log 10 is 1, so y log 0.23 is equal to 3, and log 0.23 is equal to 3 by y, and this is considered second equation. Let's subtract second equation from the first equation. We would get log of 2.3 minus log of 0.23 is equal to 3 by x minus 3 by y. So the property we have here is log x minus log y is equal to log x by y. So we have log 2.3 by 0.23 is equal to, if we take 3 common here, you get 3 of 1 by x minus 1 by y. So next we have here, if we simplify 2.3 by 0.23 by multiplying 100 on numerator and denominator, we would get 230 by 23. If we get cancelled, we get 10. So log 10 is equal to 3 into 1 by x minus 1 by y, but log 10 is equal to 1, so 1 is equal to 3 into 1 by x minus 1 by y, and therefore 1 by x minus 1 by y is equal to 1 by 3. And they told us to find if 0.23 power y is equal to 2.3 power x is equal to 1000, what is the value of 1 by x minus 1 by y, and it is the value is equal to 1 by 3. Eighth question of exercise 1.5, we have 2 power x plus 1 is equal to 3 power 1 minus x, and we have to find the value of x. So 2 power x plus 1 is equal to 3 power 1 minus x. Since x is in the power, we have to apply log on both sides. If we apply log, you would get 2 power x plus 1 is equal to log 3 power 1 minus x. And we have a property of logarithms which says log a power n is equal to n log a. Therefore, this will be x plus 1 log 2, x plus 1 into log 2 is equal to 1 minus x into log 3. If we apply distributive property here, we would get x log 2 plus log 2 is equal to log 3 minus x log 3. If we bring x log 3 minus x log 3 to left hand side and plus log 2 to right hand side, we would get x log 2 plus x log 3 is equal to log 3 minus log 2. So if we take x common here, log 2 plus log 3 is equal to log 3 minus log 2. We have two properties of logarithms here which says log x plus log y is equal to log x into y, and one next one is log x minus log y is log of x by y. If we apply these both properties in the above equation, we would get x into log 6 is equal to log 3 by 2. If we bring this log 6 to right hand side, it will go into the denominator. So, and we would get x is equal to log 3 by 2 by log 6. That is the value they told us to find. If 2 power 1 plus x is equal to 3 power 1 minus x, then the value of x would be log 3 by 2 by log 6. The ninth question of exercise 1.5. It says, is log₂ rational or irrational? And justify your answer. And the second question is log₁ rational or irrational? And justify your answer. First point, I would say log₂ is irrational. And to justify my answer, I would say this. So if there is nothing in the base, it actually means that base is 10. So we have to prove that log₂ base 10 is irrational. So if any number or any integer is rational, it should be in the form of p by q. So let's assume that log₂ base 10 is rational. So log₂ base 10 is equal to p by q. So we have a logarithmic property which says as log m base a is equal to n, then a power n is equal to m. Similarly, 10 power p by q is equal to 2. And if we multiply the powers on both sides with q, you would get 10 power p is equal to 2 power q. 10 can be written as 2 into 5 power p is equal to 2 power q. We have m into n power a is equal to m power a into n power a. Similarly, 2 power p into 5 power p is equal to 2 power q. 5 power p is equal to 2 power q minus p. If we bring this to right hand side, you would get in the denominator, and if 2 power p goes into the numerator, it would be p power minus 1. Sorry, minus p. So 5 power p is equal to 2 power q minus p. On the left hand side, we have odd, and on the right hand side, we have even. An odd number cannot be equal to an even number, so there is a contradiction here. Since there is a contradiction, our assumption is wrong. What is our assumption? We assumed that log₂ base 10 is rational. Since our assumption is wrong, log₂ base 10 is irrational. We have proved log₂ is irrational. Next we have, is log₁ rational or irrational? Log₁ base 10 is rational. To justify my answer, I would say log 100 base 10 can be written as 100 can be written as 10 square. So we have log a power n is equal to n log a. We can write it as 2 into log 10 base 10. Log 10 is actually equal to 1. Therefore, we have the answer as 2. So, log 2 is irrational, and log 100 is rational. So that's it. I hope you understood the 9 questions of exercise 1.5. The playlist of the other exercises of this chapter are given in the description down below. Go check out those and also subscribe for the solutions of the upcoming chapters. Thank you.